In the last section of hands-on, we will measure the data to low power UART, and at the end we stop the core. We have stored data as 32 bits, but only 16 bits are valid. Then we will send only the data which are necessary, and as I say, we will stop core to stop to mode. This is not easy to do it because by default is connected UART3 to virtual COM port, but we need to connect low power UART. But I choose the easiest way how to show you and connect transmit signal also to the oscilloscope. It's necessary to change 4 bridges to other on the bottom of the board, as is shown here on the picture. And now we can set low power UART in asynchronous mode on pins PG 7 and 8 and with baud rate 9600 bits. This is settings are in the communication part of the connectivity part of IOC section. And now we can set the low power UART in asynchronous mode. We must change pins to PG7 and which are here. Now I can enlarge that it was done. And now we have to change baud rate, but first we must change clock source for low power UART to low speed external. And now something strange because it wasn't changed, but now we checked if it is okay here. Go back. And now its limits are okay, and we can change baud rate to 9060 bits. Perfect. And we can continue in settings for low power UART. Now we can add 3 new nodes for input capture queue. Each node will be transferred 1 variable, but only 16 bit from in total 32. First will be LPUART 1 node 1. Which is here prepared. It will be requested by LPUART transmit. It will be transferred from memory to peripheral byte-wide, from rising edge variable to data register, total 2 bytes. Source address will be incremented. Destination address is hardware register. And 2 bytes will be transferred. Now we add new node for next variable. Request will be also from the LPUART transmit direction memory to peripheral. And data will be from this variable. Destination address will be same. Transmit data register and 2 bytes will be transferred. And now last node we add. Number 3. It also be requested by LPUART memory to peripheral with increment of source address. And okay, there will be link edge. That's it. These settings are done, and now we can generate the code. And we missed the attributes. Then we will copy from here. Between the low power timer and low power 3 timer code, it's necessary to put few lines which starts low power UART. In main C, the right place is here, and at the end of user code 2 we placed suspend to stop to mode, but at first you can try this software without this modification, and after that is put here, the core will be go to the stop to mode. If the code is in the stop to mode, the rest of code is not executed, and it means that in this case we have only raw data, and the receiver of this data must calculate the values of period. And now we can build the code. live expressions are frozen because core is in stop 2 mode, but on the oscilloscope you can see changing data and changing period. If you will measure the concept current in without stop 2 mode, it's near to 5.5 of milliampere. In stop 2 mode it's only 244 microamps, which is more better, and functionality it's nearly the same. As we saw, I'm using cheat sheet which is on github.com under ST Thomas workshops, and I want to show you this page. There is a few cheat sheets from different workshops, and if you click to this one, the content of the readme is shown, and by clicking to this link the workshop cheat sheet will be opened. There are a few more parts which was presented by my colleagues, and this what for us. Okay, thank you for attention and good luck with STM32U5 and others.